Hi there. It's Professor Monty again, and we're looking at how to factor the sum or difference of cubes. Now, the difference of squares that we did earlier, that comes up all the time. The sum and difference of cubes doesn't come up very often, but when it does, you pretty much have to remember the formula to do it. That's the only drawback to this. But the formula is really not that hard. So if I have something in the form a cubed plus b cubed, it factors into a plus b. Well, so far that's pretty easy. Just drop the cubes. It's just a plus b. And then a squared minus ab plus b squared. Well, and think this, most of this has to be, because what do I multiply a to get a cubed? Well, it has to be a squared. What do I multiply b to get b cubed? Well, it has to be b squared. The middle term, this was a plus, that's going to be a minus, and it's just whatever these two will multiply together. So a times b. And then the difference of cubes similarly starts with an a minus b. And then the a squared, this time plus ab, and then plus b squared. And a little trick to help you remember the signs, SOAP. Same sign, opposite sign, always positive. SOAP. So what do we mean by that? Well, if I look up here, it's a plus. Oh, that's the same sign. That's the opposite sign. And this one's always positive. SOAP. Similar here. With the minus, same sign, opposite sign, always positive. So if you can remember SOAP, it'll at least help you remember the signs. Probably this just AB in the middle is the biggest thing to have to remember. So let's try that on some problems. So again, I want it to get in the form of something cubed and something cubed. This time I have a minus, so I'll put a minus in the middle. Well, x cubed obviously is x, quantity cubed. 64, well that's 4 raised to the third power. It's 4 cubed. And so now when I look, oh yeah, it fits this one. So I factor using the formula. Remember, you just start with this minus that. Then it has to be this squared. Change the sign, opposite sign. Now it's just these two multiplied together. I'll just put them in the order 4x. And then it's this one squared. So what was that? Oh, that was just the 4 squared. That's our answer. The nice part about this is this trinomial often looks kind of complicated. It's always prime. So no matter which sum of cubes or difference of cubes, this trinomial is always prime. Maybe there was a greatest common factor you could factor out first, but then you would factor that out first. Other than a greatest common factor, that's always prime. You're never going to be able to factor that into two binomials. So rest assured, you can stop at that point if there's no greatest common factor. All right, let's look at this one. This one confuses students because we want to see if it's something cubed plus something cubed. But realize, well, the 8 is 2 cubed. So it's 2 times a cubed. 2 cubed is a cubed is a cubed. A 1 can be a 1 squared. It can be a 1 cubed. Since I'm looking for a cube, I just put in a 1 there. 1 cubed, of course, is 1. So again, I go back to the formula. It's going to be 2a plus 1. It's going to be 2a quantity squared, opposite sign, minus 2a times 1 plus 1 squared. And so when I multiply that out and make it nice, it's 2a plus 1 times 4a squared minus 2a plus 1, and easy as that, I'm done. The hardest thing about this is recognizing and remembering the formula. And then it's just going to take a little bit of practice plugging things in to make sure you get the final answer. And I think once you work with it, you'll find out it's not so bad. Don't be too afraid of it because you'll get it pretty quick.